situations of imminent danger, apprehension, or even anger, society has boiled down all possible actions into two categories, the fight or flight. Although societies advocate for walking away, people still like to fight it out, and there's many reasons for the divide. Exchanging blows is faster than drafting treaties, and fighting adds to social rank or masculinity in some communities. Traditions aside, there's yet to come a time when a person asks, why is a strike so effective when the occasion calls for it? By this I don't mean, why war, but why is war so mechanically effective? So I hope to take this time to explore the mechanics of combat, to explore the physics inherent in the KO, by exploring two distinct martial arts styles, karate and Tai Chi. When I say Tai Chi, you're probably visualizing slow, peaceful motions. But in reality, with practice and speed, it looks more like... It is because of Tai Chi's existence in China since the 3rd century, where a long time frame led to a long list of interpretations. Back in the day, Tai Chi was a martial art of choice for imperial bodyguards. Today, it is a practice for health. However, the two aren't so contradictory. Whichever way you slice it, Tai Chi Chuan has focused on being comfortable, curved, and centered. In other words, it focuses on controlling the body through balance and relaxation. Emulating animals with forms like white crane spreads wings or repulse the monkey, Tai Chi Chuan has become a formidable martial art and a medicinal practice. Now, before delving into the question of how martial arts uses physics in order to achieve the maximum offense and defense, it would be a good idea to examine what exactly makes these concepts martial, martial being aggressive or warlike. The history of karate is a mixed bag of sorts because of its many interpretations. However, we can trace back its roots to Western India's disciplinary practices of Zen Buddhism. It was in China where these practices started to take the shape of a martial art. These practices were later exported to Okinawa, an island off of mainland Japan. It was here that the seeds of influence fully bloomed, partly due to a ban on weapons during the 17th century. In the 1920s, Master Genshin Funakoshi introduced karate, or empty hand in Japanese, to mainland Japan, where it struck the greatest popularity. Karate became a way to defend oneself with empty hands, or in the absence of a weapon. Basically, people learned to control power through practice. Although this was how Newton's discovery of gravitational theory was widely depicted, he actually just observed an apple as it fell while drinking some tea. He later materialized these observations in his 1687 text, Principia. However, Newton was a tough guy to understand, let alone read his theories of gravitational law. It wasn't until 1736 that Leonhard Euler translated Newton's ideas into the mechanical physics we know today. Basically, he summarized his ideas into basic equations. Euler translated Newton's second law of motion as F equals ma, or, put more simply, the force applied is proportional to the mass and the change in speed of an object, which is also known as acceleration. Let's look at a simple activity, pushing objects. Here I have two different masses, mass A and mass B. If I apply a force on the lighter mass A, it will move farther than if I apply the same force on mass B. Why? Because mass B is larger and needs more force to move at the same acceleration as mass A. Overall, the bigger they are, the harder they are to move. Another concept, which has been quoted in many a political and social movement, is Newton's third law, which basically states that with every action there is an equal and opposite reaction. But what exactly does this mean? Say a force of a certain magnitude makes contact with an object. That object will respond with a force that is equal in magnitude but opposite in direction of the original force. And this can take the shape of air resistance, friction, or even drag forces. Or we can demonstrate Newton's third law with our favorite tools, rocks. Since reactions are equal but opposite, if we knock two rocks together, they will move opposite each other with nearly the same distance between them from the point of impact. Let's explore what drives motion, momentum, at Colgate University's bowling alley. Now, momentum has been defined as a relationship between mass and velocity, namely the product. So momentum, P, is equal to the mass multiplied by the velocity, which also can be known as speed. So in order to explore momentum further, we need to be able to see the differences between two masses. So here I have a bowling ball, which is approximately 4 kilograms. Then I have this nice little play ball, which is approximately 1 kilogram. that after our two examples, the more mass, the more momentum. But we could also see that the more velocity, the more momentum. So we could just boil this down into, with great momentum comes great danger. Why? Because it's harder to stop. As we previously noted, Tai Chi and Karate are two distinct martial arts. However, they both heavily rely on concepts of physics in order to get from point A to point B. Let's begin with a fist. A fist can be considered an object of a fixed mass. So if we think back to our last segment, the amount of force an object can dish out is proportional to how big it is and how fast it moves. So a very big person with a large fist and a very small, fast person with a small fist can deliver the most amount of force. When striking an object, there is a risk of pain. Here's where Newton's third law comes into play. Remember that the force of a strike will be accompanied by a reaction force from the targeted object. Punching a rigid object, like a brick, will break more bone than stone because it returns the full force of your strike as a reaction force. In contrast, striking a soft object will result in less reaction force. Why? Because the impact is absorbed by the target instead of rebound back in a rigid object. As we can see from the action-reaction pair, most of the force is absorbed by the body, resulting in a smaller reaction force. Now let's get momentum into play. Now, remember that momentum looks at how fast and how much mass is moving. So the greater the mass and or velocity, the greater the momentum. But also, the harder it is for the object to stop. However, direction plays a big part in how much of this momentum is translated into an object. Remember that velocity and or speed has both direction, where it goes, and magnitude, how much of it goes. But also remember that velocity is a component of momentum. As a result, momentum also has direction. And it is greatest when the direction is the same throughout the motion. Any force is greatest when perpendicular to the target. The object absorbs the full brunt of the force instead of the diminished force as seen with punches at an angle. Same with blocking. Redirecting a strike takes less energy and damage than taking it full force. So we go back to our beautiful question, why is a strike so effective? 1. It's indiscriminate. A person can power a punch either through mass or through velocity. 2. Direction. Strikes are often perpendicular to the point of attack. 3. Targets. With the exception of a wooden board or a piece of metal, targets are usually less rigid, so they absorb more of the impact.